Hello guys, it's your back daddy again. So in this video we're going to continue with the minima and maxima, but then we're going to do some examples. So first example will be find the maximum and minimum. Pardon my handwriting, I'm trying to be as fast as I can. Values of this function 3 to the power 4 to the power 4 minus 2x to the power 3 minus 6x to the power 4 plus 6x plus 1 in the interval 0 comma 2. Okay, so this is our example. So now this interval this is what you learned in first year. Then sometime it would be something like this, which meant 0 is part of the set, then 2 is not part of the set. So this interval has been given in that manner. Yeah, the same. Okay, so let's go to our solution. Here's our solution. So now remember, we're supposed to find the minimum and the maximum values of this function. Remember, we said at the minimum or a maximum point of a curve, the first derivative is 0. Okay, so our solutions will come from that idea, meaning if we find the derivative of this function, we must equate it to 0 for us to find the point at which the function is either maximum or minimum. All right, so that's why you need to understand the introductory video so that this won't give you problems. So let's start. We can say let f of x be equal to 3 to the power 4, then that's 2x3, then that's 6x, then that's 6x, and then plus 1. Alright, then we're supposed to find our first derivative, which is equal to dy dx. So as I'm writing, this is a way you can write like this in your tests or your exams. This is a standard way of presenting your work. So our derivative will be, so yeah, and then we have 12 there, and then we have 6. Okay, so dy dx will be equal to that. So now see so let's do this. So this is you presenting the work. So now what you can say is at either maximum or minimum, dy dx is equal to 0. Wait, in fact not either, at both. So what do we do here? What we do is we equate this function to 0, since we're saying at maximum or minimum dy dx is equal to 0. Alright, so now we're supposed to solve this, but see, this is 12 and this is 6, this is 12, this is 6, so we can divide this by 6 so that we reduce the function. Then here we're going to have this, and then and then here we're going to have, here we're going to have 1, meaning it's just going to be, and then here we're going to have 2x plus 1, which is equal to 0. Right, so now we're supposed to solve this. So we're basically supposed to solve for x. So now to solve for x, this is not a quadratic function. This is not a quadratic equation. This is a polynomial, meaning we have more than two powers. I mean the power is more than 2. So this is a polynomial, and we can use the concept of factor theorem. Okay, factor theorem from non-quarter, if you can remember. So what we do here is that we're going to assume it's a trial and error thing. We're going to let x be equal to, let's say, 1. This implies that we have this factor, right? So then when you equate this to 0, then you're going to have x is equal to 1. So x is equal to 1. X is equal to 1 is this factor. So we're going to have x, f of x. Let's see what f of x will be. So f of x will be, okay, if you check from your calculator, you find that this will give you 0, because this will be 2. Okay, let's just do it. This will be 2, and then this will be 1, and then this will be 2, then that will be plus 1. So 2 and 2 cancel each other, and that, so we have a 0. This means x minus 1 is a factor. Okay, then once you find one factor, what you go to is called the synthetic method. So basically with this method, we're reducing this polynomial to a lesser power, and since we have power 3, reducing it will mean we're going to remain with power 2. So what we do is we draw something like this, and then we draw the powers of the original function which we are trying to reduce. So its powers are, so if we check, we have 2, and then we have 2, and then we have negative 1, then we have negative 2, and then we have 1. Okay, so we have 2, and then we have negative 1. What else do we have? We also have negative 2. What else do we have? We have 1. Okay, and then on this point here, you put the factor, the number, which is this number here, so we put 1 here. Then we'll do the synthetic. So we drop these 2, and then there's multiplication here. When you multiply this by that, we put the answer there. So 2 times 1, we have 2, and then you add them. When you add this, you find we're going to have 1. So 1 times 1, we're going to have 1, and if you add this, we're going to have negative 1. Then negative 1 times 1, we're going to have negative 1, and then if you add them, we're going to have 0. Make sure if you said this was a factor, you should have a 0 here. If you don't have a 0, then either this wasn't a factor, or you have done something wrong with the synthetic method. Take note of that. So from here, what we have is the function will be this. Since we already have this, so we have factorized already this, then we begin to get this 2, the power is reduced by 1, and then we have this one, which will just be x, and then minus 1. Okay, minus 1. This is, so now from here we can still factorize this, so we can take this is your quadratic. Now this one can be solved, so this one can be solved. So we have the product. For those who want, the product will be negative 2, then the sum will be 1, then the factors will be the factors that when you add them, they'll give you 1, then when you multiply them, they give you 2. They'll give you negative 2. We're going to have 2 and negative 1. Alright, so 2 times -1, that's -2, then 2 plus -1, that's 1. So then we have this here, we have 2, and then we have -1, and then we have 1. So we can factorize this. We have this 1x plus 1. So we have something like this now. Something like this. Remember we already have x minus 1, therefore f of x is equal to x minus 1 then to x minus 1, and then we have x plus 1. So wait, this isn't f of x, this is f inverse. Oh, this is f prime, which means the derivative of a function. So that we said it should be 0. So if it's going to be 0, then this is 0, or x plus 1 is 0, or 2x minus 1 is also 0. So meaning x is equal to 0, x is equal to 1, and x is equal to -1, or x is equal to 1 over 2. Alright, so this one is not part of this. If you remember the given range, this is from 0 to 2, the numbers in between, meaning -1 is outside the range. So we're not going to find anything for -1 because it's outside our range. So this one is already cancelled. So now we're going to find the second derivative, because remember, on the second derivative, to test whether the function is maximum or minimum, you find the second derivative. Okay, so what we were doing is we were finding the stationary points, because where a function is stationary, that's where it's either maximum or minimum. That's where there's a turning point in simple terms, right? So for us to find the maximum and the minimum here, we're going to find now the second derivative. So the second derivative of our function will be, the second derivative of our function was our function. So the original function is this. No, the derivative is this 2x to the power 2, then we have minus 2x to the power 2 here, then we have I don't know if I've written it correctly, but I hope so. Oh no. So this here should be 2, then this should be this. Okay, then we're going to find the second derivative. Second derivative is 6x, and then that will be that. Okay, so we'll test for whether minimum or maximum at this point. So then what you do is f of x at a point 1, what's its sign? So we'll find this, then okay, here we're going to have 6 minus 2 minus 2. Oh wait, sorry, what should be equal to 2. So 2 is positive, so since it's positive, it's minimum here. Remember we said if d squared y dx squared is less than 0, then it's maximum. Otherwise, if it's greater than 0, then it's minimum. So here we say f of x is minimum at 2. Then we test at half x is equal to 1 over 2. This will be 6 1 over 2. Yeah, you can use calculators in MA 210. It's not like MA 110 or 310. So here, so we're going to have 6 times 1 over 4 minus, this will be 1, then minus 2. So this will be 3 over 2 minus 2. So remember, this is 1.5 minus 2. Definitely this will be negative. So since d squared y is less than 0, this means we have a maximum here. So you write a statement to say at half f of x is maximum. Alright, then remember the question says find the maximum and the minimum values. So then to find this, we get the stationary points and then place them in the original function. So the original function is f of x is equal to 3x to the power 4 minus 2x to the power 3 minus 6x to the power 2 plus 6x plus 1. So at this point 1, we have a maximum. So we have the maximum value at this point. So we're going to find the maximum value for minus. So here we have this, here we have this, here we have this, then plus 1. Then this will be 3 minus 2 minus 6. Then we have plus 6, then plus 1. So this is 3 minus 8. By the way, this is 0. You guys can be using calculators. So this is 0. So we just have this plus 1. Then this is 3 minus 1, and that is 2. And that is 2. So therefore, since at 1 we had a minimum, remember, but at 1 the function is minimum, so the minimum value is 2. Then we go to find the maximum value, which is at half. Sorry, the maximum which is at half. So our maximum will be 3. So wait, 1 over 2, then 1 over 2 squared, then plus 6 plus 6, 1 over 2, and plus 1. So here now you can use a calculator. So we have 3, 1 over 2, 3, 1 over 2 to the power 4, then minus 2, 1 over 2 to the power 3, then minus 6, 1 over 2 to the power 2, then plus 6, 1 over 2. Here use a calculator, guys, don't stress your head. So it's giving us 39 over 16. So you even write a statement, therefore we said we have a maximum at half. The x value is 39 over 16. Alright guys, so this is how we can apply the concepts of maximum and minimum in this in such a case. We're going to do another one where we can, in the next example, we're going to do where we can see if what to do when the second derivative is equal to 0. Alright guys, catch you in the next video.